Hey everyone, Mr. Newman here, and today we're going to look at tabular and graphical derivatives and learn how to take the derivatives if the numbers are given to us in a more abstract way. So from this first one you see we have here a table where they give us a few values. Okay, they give us the function at the value and they give us the derivative at certain values. And so this first one we have 4f of x plus 2g of x, and you know the derivative rules. And when we have a constant, we can just leave the constant out in front and take the derivative. And so I'm actually calculating h prime of 3 here. Notice a few things here. I just went ahead and plugged in the 3. I could write it all out and put x's and then plug in the 3, but that's just an extra step I'm just kind of skipping here. So we take the derivative of 4f of x and we get 4f prime of x. We take the derivative of 2g of x and we get 2g prime of x. And so this is what we'll be doing throughout this. I just want to show you guys what it looks like this first time. And notice now we can just look at the table. We know that f prime of 3, that's going to be that 5 there. So you see that's how you read the table. You follow the x's down, find f prime of 3. That's going to be 5, so it's 4 times 5. Plus 2 times g prime of 3 is going to be right here. Notice that because it's the 3 here, it goes all the way across. And that's g prime of 3, okay? So you get -2. Then you just multiply them out, and you get 16. So that's the way you do these kinds of problems. The tricky thing, though, is you have to watch out for the various rules. You can't just take the derivative and throw them in there like that all the time. For example, this time, number 2, we have the product rule. And so if we're using the product rule, remember it's the derivative of the first times the second plus the first times the derivative of the second. Okay, and notice the 4 just is a constant, so it floats out there in the front each of those. But I went ahead and plugged in the 2's, but you can see that is the product rule, f prime times g and f times g prime. And I will say a few things. If you want to think of it as 4 times all of that stuff and leave the 4 out in the very front, you could do that as well. I actually do that later for a quotient rule. I find it easier for quotient rule especially. But you can end up getting the same answer, okay? So there are a few different ways to tackle this, but as long as you make sure you watch out for the product rule, it is not just f prime times g prime, right? You have to follow the product rule. So when we substitute these in, we get 4 times -4 times 3 plus 4 times 2 times -8, and that's all taken from the table. So multiply that out, add it together, you get -48 plus -46, which gives you -112. All right, moving along, we do have the quotient rule here. And like I mentioned, I'm going to just bring the 8 out in front and then do the quotient rule. It's a little bit less writing that you have to do on the inside. It's really, you'll get the same answer in the end. It's not a whole lot less writing. But let's go ahead and do the quotient rule. So we have low d high minus high d low all over low low. That's g of 3 squared. I could go ahead and put the parentheses there, though that is extra because the function takes precedence when there's a function and an exponent. But I'll go ahead and write that in there. Now it's a matter of plugging in all the values. So we get 2 times 5 minus 3 times -2 all over 2 squared. And notice I did the 8 divided by the 2 squared. That gave me a 2 out in front instead. That was just a quick shortcut, and the answer there is 32. Which I can write up there as well. All right. No, I already wrote it up there. Cool. So for number 4, we this time have an inside function and an outside function. So we're going to be using the chain rule. So let's write it down. Again, I'm going to go ahead and replace all the x's with 3's because we're substituting 3 in. So chain rule, I'm going to pull that the 3 from the cubic down in front, and the cubic turns into squared. Remember, you leave the function on the inside alone. So that means I'm going to have f of x, or f of 3 on the inside. But don't forget to multiply by f prime of 3 on the outside. When we plug in those values, we get 135. All right, moving on. Same table, we're just lower on the paper. Again, we have chain rule here. Notice that. So we've got inside and outside. F is our outside, G is our inside function. So we're going to take the derivative of the outside and leave the inside alone. By leave it alone, I mean we're not going to take the derivative of it yet. But then we're going to multiply by the derivative of the inside. So for this one, we actually have to do this in multiple steps. So we're going to find g of 2 first. Notice g of 2 is 3. And we also know that g prime of 2 is negative 8. And then we take f prime of 3. And I can already see people asking, well, what if you have to take a derivative of something that doesn't show up on the table? Well, you can say it's not defined, but I'll tell you now, they will give you values that show up on the table. You can say these are the only values given on the function, but it always works out on the when these kinds of table problems, okay? And you get negative 40 for the first one. For the next one, it's also chain rule. I'm going to leave the 8 out in front. That just stays out in front the whole time. So we have 8g prime and leave the inside alone, f of 2. Then you multiply by the derivative of the inside. And again, we're going to have to do this in 2 steps because we have to find what is f of 2 first. Then we can find what is g prime of 2. And we multiply all this together, you get positive 256. Moving on, number 7. It's another chain rule. So leave the negative 2 in front. F prime of leave g of 3 alone, but then multiply by the derivative of g. Got to find g of 3 first. Then we can find f prime of 2. And when you multiply all it together, you get negative 16. Go ahead and try number 8 on your own. All right, hopefully you got it done. So you got chain rule on the inside, g on the outside, leave the inside alone, then take the derivative, or find f of 3, so that you have g prime of 3. And you should have gotten negative 5. All right, more of the same this time. I want you to try these on your own first, and then I'll show you how to do them. So notice this first one was a chain rule, h prime of 3. Bring the 12 out in front, leave the g of 3 alone, but then we multiply by the derivative of g of 3. Plug those in. You do get a large number. It's fine if you have to write this on the side. 12 times 16 gives you 192. And so double that and add a 0. Whoops, I forgot my 0. There we go. You get negative 3,840. Moving along here, this next one is another quotient rule, so I'm going to bring the 2 out in front. Low d high minus high d low, all over low low. When you plug all those in, you get 2/9. For number 3, this is pretty much run of the mill until you get to f of x, g of x, where they try to trick you and make you skip over the fact that's actually product rule. So we've got to do derivative of the first times the second plus the first times the derivative of the second. And when you substitute all those in, you end up getting, it's actually a lot of 8s. It's a pretty neat pattern. You notice 2 times 8 and 2 times negative 8, they add up to 0. 4 times 8 plus 3 times negative 8 is going to be 1 times 8, also known as 8. For number 4, this is a chain rule. Notice you have 2x on the input. So we're going to do the derivative of the outside, leave the inside alone, and we're plugging in 2, so you can get a lot of 2's in there. Then multiply by the derivative of the outside of the inside. Well, the derivative of 2x is 2, so we're going to have to multiply by 2 at the end, just like that. Find f prime of 4, and we get 3 times 2, also known as 6. Last 2, I would like for you to try this one on your own. Now that you've tried it, I would write it first as g of x to the 1/2. And notice I went ahead and color-coded because, yes, it is chain rule. So we're going to do, bring the 1/2 down. 1/2 minus 1 is negative 1/2. G of 1, Then we also have to multiply by g prime of 1 because you have the chain rule. Don't forget to multiply. So we get 4 on the inside. 4 to the negative 1/2 power, well, that's going to be 4 to the 1/2 power, which is the square root of 4, which is 2. And then the negative makes it a reciprocal. So we get 1/2 times 1/2 times 7, also known as 7/4. For number 5, you could do this as chain rule of a chain rule because you have the cube root and then squared and then f of x working inward like this bizarre telescope. But you could also do squared to the 1/3 power. That's going to make the f of x to the 2/3 power. In my mind, that simplifies that a whole lot more than trying to do multiple chain rules. So we just have one chain rule to deal with. So bring the 2/3 out in front. 2/3 minus 1 is negative 1/3. Notice we left f of 4 on the inside, and f prime of 4 is multiplied by the outside. Well, the nice thing about f of 4 is it's just 1, and 1 to any power is just 1. So we have 2/3 times 3, also known as 2. All right, now we get to graphs of piecewise linear functions, and notice we're going to have to find the derivative without being given a table. And this is where it's very helpful to remember that the derivative is the slope of the tangent line, okay? We have the original functions here given, but we're going to need to remember that the derivative is the slope of the tangent line. And before you go, wait, what's the tangent line of a line? Is actually a special case here. If you have a linear function, it's just the slope of the linear function because the derivative, remember, is measuring the instantaneous rate of change. And in this case, the instantaneous rate of change is the same as the average rate of change. The slope is just the average rate of change on a line. Now these are piecewise functions, so they change, but we're just going to use the slope here, and it's going to be very much the same as as what we've been doing up to this point. So for this first one, let's use the quotient rule. So first we have to apply low d high minus high d low all over low low. And then we're going to look at the graphs to examine what is g of 4, for example. Well, okay, first of all, you notice right here, we're going to be looking, that first graph is f of 4, is the f function. And so f of 4 is right there. But the slope at that point is 0. That means that f prime of 4, the derivative at 4, is also 0 because it's the slope of the line at that point, since they're linear functions. For g of x, the slope right there at 4 is negative 3. So that's equal to g prime of 4. In other words, the derivative, or the rate of change, the instantaneous rate of change at 4 is negative 3. So we have those values, of course, to get f of 4, for example. That's the y value over there, 6. And g of 4 is 3. So we're just going to plug them in like we have the table. 3 times 0 minus 6 times negative 3 all over 3 squared, which gives us 2. All right, for the next one, we have a product rule. So we're going to do derivative of the first times the second plus the first times the derivative of the second. Well, if you look at this, those 2 points, both of them are not continuous. And this is where it's really important that you understand the technical definition of continuous. I know I've given the brief version is if you can draw without picking up your pencil. And yes, technically you can draw these without picking up your pencil. However, look very carefully. These functions do not continue past 8. At least we're not shown that they do. And so we have to assume that they don't. And the limit from the right, therefore, doesn't exist, which means that the limit doesn't exist as x approaches 8 for either of these functions. And if the limit doesn't exist, then it can't be continuous, because remember, that is one of the conditions of continuity. The limit has to exist. So because these are not continuous, remember, continuity a function must be continuous for the derivative to exist. Therefore, the derivatives are undefined. Yes, we can find g of 8, and yes, we can find f of 8, but we cannot calculate f prime of 8 or g prime of 8. So that entire expression is undefined. Looking now at number 9, we first take the derivative, we get 2f prime of 3. We'll look very carefully at the function when x is 3. Since this is a piecewise function, there's a funny bend there, and since that is a sharp turn, remember one of the ways a derivative cannot exist is if there's a cusp or a sharp turn. This constitutes a sharp turn because we cannot calculate the derivative here because there's kind of two tangent lines, two lines that meet at different angles. It's not a slow, steady, gentle turn. Therefore, the derivative is undefined at this point. So because it's a cusp or sharp turn, the derivative is undefined, so we cannot calculate h prime of 3. Moving on, let's try to do the next one. We do need the chain rule here. So we're going to find first g prime of f of 1 times f prime of 1. For this, f of 1 is 2. So we're going to need to calculate g prime of 2 now, times f prime of 1. Well, the slope here, rise over run, is 2. So that's just going to be 2. G prime of 2 means the slope at 2, and that has a slope of 1. So the derivative of that is 1. So we get our final answer is 1 times 2, or just 2. For number 11, we do have a chain rule here, but they give us what r of x is equal to. It's just x squared. So let's go ahead and substitute that in before we do anything. And now when we take the derivative, we'll apply the chain rule and know what to write. So we get g prime of, we have to first leave it alone. So I'd write x squared, but remember we're plugging 2 in for x. So it comes out to 2 squared. And then we also have to follow the chain rule, so we multiply by the derivative of the inside. Well, the derivative of x squared is 2x. But remember, x is 2 here, so it's going to be 2 times 2 instead of 2x. And that means we have to find the derivative when g is 4. We already did that on the other slide. That is -3. So it ends up being -3 times 4, also known as -12. Thank you very much for watching.